All right, so I want you to take a mental picture of this. Again, in the decimal numbering system that we're used to, base 10, these are the digits that we have available to us. There's 10 of them, starting from 0 and going up to 9. When we run out of digits, we push out to the next position, starting again with 1, and we make this position a 0. Okay? When we, in this case, we have a 19 and we add 1 to it, then we'll move to a 20 and so on. And eventually, as we get, I guess, to I should have done this, as we get to a 99 and we add 1, what's going to happen? Well, we're going to get a 0 here, and then we get a 9 plus a 1 there, which is going to give us another 0 here, which is going to push out to the next digit, and that in decimal means 100 things. Okay? And then we talked about the positional value of each position. The numbers in this slot right here, this column, are worth 1 each. So if I have 5 of them, that's 5. The numbers in this column are worth 10 each. So I have 6 of those, that's actually 60. The numbers in this column are worth 100 each. The numbers in this column are worth 1,000 each. The numbers in this column are worth 10,000 each. So let's see how those same principles apply then to a base 2 numbering system. You've heard it said before that computers can only speak in ones and zeros. That's the only options they have available to them. And what that actually means is it's either on or it's off. The electrical signal is either there or it's not. And so in the world of base 2 or binary numbering, we only have 2 options. We have a 0 and we have a 1. It's either off or it's on. Off or on. Or sometimes we'll refer to it as this is false and this is true. But what all of these things mean is there either isn't an electrical signal or there is an electrical signal. And everything your computer does, this is the amazing thing, everything your computer does is based on those electrical signals. But it all comes back to binary. And you've heard this word before, and we're going to make it so it's second nature. That's the idea. So what happens then if I only have 2 digits? I get, let's say, 2 apples on the table, and I want to count how many apples I have on the table. Well, I had 1 apple, and I'm going to add 1 to that. What happens? And again, this is in binary. This is in base 2. If I get a 1 plus a 1, there are no other digits. I can't say 2 because there's no 2. And so what do? Well, the process is exactly the same as it is in the decimal numbering system. I put a 0 here, and I put a 1, 0 here. And that represents a 2 in base 2. The way we'll indicate that is with a little subscript here. That is a 2. We say that's a 1, 0 in base 2 numbering, which is different than a 1, 0 in base 10 numbering. Okay? So you've just done your first binary conversion. A 1, 0 in binary is a 2 in decimal. It's equivalent, right? So forget about that. That was something different. But if we look at this, a 1, 0 is equal to a 2 in base 10. Which you'll now get the joke. One of the classic computer science jokes is there are 10 kind of people in the world. Those that understand binary and those that don't. It's little computer science humor. Okay, so what happens then when I say I want to count another apple? Well, I take my 10, I add 1 onto that, and that gives me a 1, 1, again in base 2. Well, what's a 1, 1 in base 2? Well, we know because we just added one, that's a 3, but that might be a little bit hard to figure out. So let's come back over here to this idea of positions and positional value. So let me just take 4 positions. And remember, we start at 0, and then we go to 1, 2, 3, and 4. But this time we're in a different base. We're in a base that only has 2 digits. So base 2. So I'm going to take 2 to the power of 0. I'm going to take 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So 2 to the 0 is what? Well, we know it's always going to be equal to 1. So the digits, anything in this spot is worth 1. 2 to the 2, anything here is going to be worth 2. Anything here is going to be 2 to the 2 is 4, worth 4. And anything here is going to be worth 2 times 2 times 2, which is 8. Okay, so any digit in this this column is worth that many digits. So if I get a number like 1, 1 in binary, what is that? Well, I've got a 2, I've got 1, 2, and 1, 1. What's a 2 plus a 1? Well, that's a 3 in decimal. So a 1, 1 in base 2 is equal to a 3 in base 10. And we just keep going, you know, so on and so forth with the counting. So what happens now if I take that 1, 1 and add a 1 onto that? Whoops, sorry. This is my first use of this. I was doing so good. Okay, so if I get a 1, 1 in binary and add a 1 onto it, I've got the same exact issue. There's no such thing as a 2 in binary. So this 1 and 1 becomes a 0. Carry the 1. 1 plus 1 is also a 0. Carry the 1, and I get a 1, 0, 0. What is a 1, 0, 0 in binary equal to in base 10? Well, if I go and look, if I've got a number with a 1 in that position, I've got 1, 4. Just like I had 1, 100 in base 10. I have 1, 4. So 1, 4, and then these are both zeros, right? Everything else is a 0. So a 1, 0, 0 in base 2 is the same thing as a 4 in base 10. All right, and so just to kind of finish this thought, if you picture what's happening, so in decimal numbering system, so this is base 10, okay? I have a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? In base 2, I can also have a 0, and I can also have a 1. But when I get to a 2, I have no option for 2, because all I have is a 1, 0, and a 1. And so that becomes a 1, 0, and then we just keep counting, just like we would in decimal. And then a 1, 1, and then a 1, 0, 0, and then a 1, 0, 1, 1, 1, 0, 1, 1, 1, and then 1, 0, 0, 0. And then a 9 would be 1, 0, 0, 1. Okay, and so these things, this 0 and the 0 are equivalent, 1 and 1 are equivalent, 2 and 1, 0, 3 and 1, 1, 4 and 1, 0, 0, 5 and 1, 0, 1. It's all the same principles. There isn't a huge mystery here. It's the same thing we do in base 10. We're now just doing it when we have a limited number of numbers. All right? So that is base 2. Now what we're going to do next is talk about base 16. So we'll go there in the next video. Spencer out.